Hi everybody, thank you Marko for your introduction. Hello everyone in Croatia. It's been quite cloudy and gloomy, but only in northern part of Croatia, and in the south it's still sunny and mostly nice. So let's introduce ourselves. Could you please put little stars or arrows where you're from? Okay. Mostly west part and middle part of Europe, and someone from up north. Okay, Valentina, very far to the east. And we have Nadur from Africa. Okay. Okay, so let me just tell you a little bit how the weather was in Croatia in last almost 3 weeks. It was really stable weather. We had no rain and stable weather conditions. So during the night we had fog, and as you can see here, this is from Sunday. It was really foggy. We even had fog on the seaside, which was quite unusual. It's not that it never happens, but it's quite rare. It's because the gradient of the pressure was really low and there was almost no wind at all, so we had really foggy and quite cold nights. We had even some minus degrees in the morning, but what I want to actually talk about is the day temperatures, which, as you can see, these are the mean deviations of maximum temperatures from October 1st till 28th. So until yesterday, the temperature was really quite high, above the average in the daytime. It was more pronounced in the inner parts of Croatia than on the coast. So if we take, for example, it's from the 22nd, these are the maximum temperature values on our main synoptic stations. And maybe if you just take a look at the temperatures here, for example, this is the value you would maybe expect in the summer, beginning of summer or at the end, and not so late in October. For October, usually the temperatures inland are around 15-16 degrees, and at the coast around 20 to 22 degrees, so quite high. But the situation is changing, and as most of you have sent hello from rainy Salzburg or another part of Central Europe, we can see that there is some things actually happening right now, and it's not the influence of a ridge anymore. So first, I would like to ask you all to draw, where do you think on this image is the jet stream? So, as you can see, this part was really easy to spot, and then here as well, because we can see this orangish kind of color, which indicates the folding of the stratosphere. But there is also jet stream here and here, which is actually from the ridge, really strong ridge in this area. So if we go further, now please can you show me where do you expect frontal areas? So it can be either cold front or warm front or occlusion. Okay, so if we take a look at the frontal parameter in ePort, you can see that all the answers were correct. So this is warm front, this is an occlusion. This is kind of a stationary front. It's connected with the two air masses, which we can really easily spot. So this is a warm mass, and here we have the advection of really cold air mass. So if we take a look at the vertical cross-section, then we can really easily spot. So here is the north, here is the south on this side. So it's really easy to see where the front is. And if we take a look at the advection, there is almost no advection in this area. That's why I said it's a stationary front. So what we actually see is that there is like a little wave here forming, and here we have a formation of a low center. What else I wanted to say is actually that there is still in the lower atmosphere, it's really still high pressure on most of the northern part of the continent. So what we expect in Croatia is now here the advection of really moist air coming in, giving rain, mostly in the northern and western parts of Croatia, while the Dalmatia will be staying dry. And since it's still really high pressure, the frontal system will be slowly decaying, while the low that's forming in near Genova will keep its place mostly stationary, or come a little bit closer to the western part of Italy. So what happens in Croatia during that time, because of the high gradient of this low pressure near Genova, and then growing pressure from the north, and also the cold advection, we are expecting Bora wind, and it should be quite strong. We are expecting strong to stormy Bora, mostly under Velebit Mountain. So we are not expecting a lot of rain, since, as I said, the front is going to slowly decay. But what is expected is maybe a bit of snow in the highest mountain areas. And now Marko will tell you a bit more about rapid cyclogenesis.
Okay, hello everyone again. I will just take this case of rapid cyclogenesis I saw just a couple of days ago, actually yesterday and the day before, and show you how it developed. Actually, you could have seen the remains of the cyclone on Kristina's on images just before. Basically, what I want to show you, that when you have something like this, some remains of frontal cloudiness, some cloud heads, bulge of cloudiness, and you have some kind of pinkish tones in the air mass RGB, you can assume there is some kind of jet there, either remaining of some other system, or just that developed there. You have a little low over the cloud head, and as you can see, there is in the isotext, you can quite clearly see the jet stream. And because the cloud head is on the left exit region of this jet stream, you can have the cyclonic vorticity advection, quite strong cyclonic vorticity advection over the head, which means that the system, actually the future system, can start to develop from this bulge of cloudiness. If we continue, so 6 hours after this time period, on October 27 at 6 UTC, you can already see how the system started to develop because of the cyclonic vorticity advection and this jet stream and everything. You can see how a really nice signature at geopotential height 1000 HPA and 500 HPA is seen. It is really a characteristic feature for this type of cyclogenesis. If we go forward, we are still at 6 UTC that day, but we can see a very strong dipole of advection, so very strong cold advection on the left side and a strong warm advection on the right side on the system, in the system. Already, actually, you can also see some kind of front, a cold front, and an occlusion. If you go forward a couple of hours more, you can also see that the pressure has already in the last 12 hours dropped for 23 HPA. So for you that don't see it, it's currently 978 HPA, and the starting one was 1001. So the cyclone has already developed quite nicely. The fronts are seen very well, and if you pull the vertical cross sections through it, you can see how they actually look, how strong is this cyclogenesis. The PV anomaly that is also very characteristic for this phenomena goes down to, let's say, 700 HPA, which is quite low. And if you look at the wind, which is also a characteristic feature for this type of cyclogenesis, because the winds in rapid cyclogenesis are getting quite strong, especially at lower levels. And as you can see here, you can have winds up to 30 meters per second down to 850 or 900 HPA. Of course, we don't have, unfortunately, we don't have any observations because this is in the middle of the Atlantic Ocean. But yeah, maybe from some other point of view, it's fortunate because there are no people there, or maybe some ships only, so no damage was probably done by the system. So up to 30 meters and more near the ground. Also, the jet streak is also prominent just above the system, and it is also a characteristic of it. As I said also earlier, in 6 hours ago, actually, there was also a very strong cold advection, as it is now. You can see here a very strong advection going on in this here area. At the end, we can see how the cyclone looked on 28 October at 00 UTC. The total pressure drop was 33 HPA in 24 hours. So for that matter, it is classified as rapid cyclogenesis. As I already said, many other features are characteristic to the rapid cyclogenesis, and yes, we can say that it was fortunate that it was nowhere near the land, so there was no strong wind in near of infrastructure or buildings or people, let's say. Okay, so after this short case about the rapid cyclogenesis, I would just like to go a bit to the future of our satellite meteorology here above Europe, actually. Of course, this image is not above Europe, but is southeastern US, but we'll make just a short case or just a few pictures about that, about some RGBs that will be available with the MTG. You can see some of the new channels that will be available, the 0.4, 0.5 that will be used for true color RGB creation, the 0.9 that will be used for total column water and actually in general moisture during the day, of course, 1.37 for thin cirrus detection, 2.25 for microphysics, so additional one for microphysics. You cannot have too many of those. And the 3.8, which is basically just switched from 3.9, which will have better fire detection. And also some of the channels are just switched to have better characteristics to measure, for example, the temperature better at their own wavelengths. Okay, so here you see there's nothing new. This is just a natural color RGB from the GOES satellites on 27th October at 5:50 UTC, actually 17:50 UTC. All the same old channels, 1.6, 0.8, 0.6. And now I would like you to mark where do you see the ice clouds. Actually, what do you think, where are the ice clouds on this image? First that, and then later I will ask you one more thing. Okay, yes, of course, you all know this product. It's already out for about 17 years or something like that, if I'm not wrong. Most of you have selected correct, and yes, I will just clear all annotations for the moment. And pointers. Good. Good. This is very important actually for the next image. We will see it very shortly. Now, for this quite big cloud, low cloudiness actually, do you think, or can you maybe show me, is there some areas of the cloud where you think there are particles of different sizes, of larger particles of water or smaller particles of water? You can either answer it in the chat box, yes or no, there are no smaller or bigger particles, or you can try to annotate. Okay, some of you have almost selected almost the whole cloud, but okay, yes, I see some good thoughts there. Yes, good, thanks. I'll just clear all of this. Now, since we'll have some new channels on the MTG, we will have some new RGBs, as I already said. And one of the RGB that we'll have is the cloud phase RGB that actually tells us what is water, what is water with large particles or small particles, and ice with small or large particles. And as some of you have actually selected for the ice particles, these clouds actually here in the Atlantic, you can see that actually, yes, on the natural color they appear cyan, in cyan color, but here they appear more like pinkish or purplish, which means that they are actually water clouds. So we have an additional information from this 2.2 channel that we have just mentioned some moments ago. Most of the clouds here, of course, are ice some of the ice is more dark, which means the particles are smaller, and some of the ice clouds are brighter, which means it's the particles are smaller. Sorry, I think I missed something. The darker particles, clouds, the particles are large, and the bright clouds, the particles are small. Sorry. But also, yes, if you switch the images back and forth, you can see that many clouds, actually in the natural color RGB, seem that they are icy particles, icy clouds, sorry. But in the cloud phase RGB, you can clearly see the distinction between the two. And you can see that mostly the highest tops of the clouds are only icy, while everything else is, watery. Good. So now to continue, I would like to ask you to mark the thin cirrus clouds. You can use the pen, not the highlighter, because the highlighter will not be very visible over the ocean if you'll go there. So you can mark the thin cirrus high icy clouds. Okay. Good. We have some cirrus, we have some watery clouds actually selected, but okay. Never mind. Good. Let's just switch to the next slide, and let's see another product from the future channels that we'll have. Is the cloud type RGB, and here the new channel is 1.3. As I said already before, this channel will give us information about very high and thin cirrus clouds. So basically, this is a very good product for detecting them. And as you, just let me see, yes, most of you selected many actually thin cirrus clouds. There are also some missing. For example, here there is one very thin, very small thin cirrus. But okay, that's maybe not that important. But in general, you can see that the thin cirrus clouds are highlighted in quite bright red color on this RGB, and simply cannot miss them. So for some purposes, I believe, I'm not sure for what purposes this product might be used, maybe for some climatological or maybe something else where thin cirrus clouds are needed. You can use it very well to distinguish high and lower clouds. Okay, one last thing actually, one question for you. You can use the little text toolbox in the annotation tools on this natural color RGB and select one of these numbers and put it beside these three features that you see here. So what do you think? Is the feature that you are looking at a lake, a cloud, sand, vegetation? What do you think? Let me just point maybe more clear to the features I want you to identify. So this, the upper left, this, and this. Okay. Features in this image. I believe the upper right is quite obvious also, but the other two, let's see now. Okay, so what does actually natural color RGB give us? It gives us some info about the vegetation and basically about the clouds. Are they water or are they ice? From this image, basically we can almost already see that this is a cloud. And let's say we can assume it is a watery cloud. We can see some small cloud streaks or maybe gravity waves or something like that at the edge. But the other two, for the other two, we need some kind of confirmation from other RGBs. So for example, for this one, this in the south, it looks like a cloud. But if we switch to the cloud face RGB, we can see that the two features to the north are, well, almost the same color, while the south feature is really pink or purple, whichever color this is, which means that the contributions from 1.6 and 0.6 are very high, which means basically that the signal is coming from the ground because 1.6 and 0.6 are getting the signal from the ground, especially 1.6, because if you look at the natural color RGB, actually you can see that, for example, the deserts are reddish and the red color is in the 1.6 channel. So this is something at the ground, and it is, I believe it is called white sands in New Mexico. It is basically a national park or something like that, like a part of a desert with very white sand. But these two, for example, okay, let's see, natural color RGB told us that we have here something like a water cloud, and the cloud phase RGB also says that it's basically a water cloud with small droplets. For this, we are still not sure because it doesn't look like a very low cloud. So if we switch to the cloud type RGB, we can see, okay, this is what we said, sandy area. This is again something bluish, which means that it's a water cloud. And as we said from the previous image, it's a water cloud with small particles, and this here is very bright red, which means it is very high. But as we said before, on this image, very high clouds can be bluish or something like that, but we didn't mention very, very, very thin clouds. So basically, if we have very thin cirrus clouds in the cloud phase RGB, we can have this grayish cloud that is actually a high cloud that is confirmed by this cloud type RGB. And so, for example, these are some features of the new channels and new products from the MTG, and I'm looking forward a lot to get some more data from Europe actually in a couple of years when the satellites will be launched. And basically that is it. We are actually on time, half an hour. Thank you for your attention. And as you can see here, the next weather briefing will be at the end of November. It will be held by DWD. And for all of you that did not see maybe the announcements, please check out and register for the HSAF event week that will be held next week, and check out the road weather event week that will be held at the beginning of December. So thank you all for listening, and we will take some questions now if you'll have some.